This video accompanies the 1.5 additional practice, and for this first part we want to write each sentence as a conditional. Conditional if, then. So let's think. Regular hexagon has exactly 6 sides, so if a polygon is a hexagon, then it has exactly 6 sides. Okay, let's look at the second one. 2 supplementary angles form a line. If 2 angles are supplementary, then they form a line. Then they form a line. And for these, it's not really asking us to evaluate these. They just want us to write them, so we're good on those. Here we want to evaluate these, determine the truth value of each conditional, explain your reasoning, or give a counterexample if it's false. So let's see. If a figure has 4 congruent angles, then the figure is a square. So let's look at our truth table. If we have P, Q, value, if P is true and Q is true, the statement is true. If P is false and Q is true, the statement is true. If P is false and Q is false, then we take the statement to be true. And then if P is true and Q is false, the statement is false. So I kind of did these in a little bit different order with the rows than you might see on your actual table. Okay, so let's take the if part. Figure has 4 congruent angles, then it's a square. Okay, let's see. What if I did a pentagon? See, 1 right angle, 2 right angles, 3 right angles, 4 right angles, and well, pentagon didn't come out, but I made a rectangle. These 2 opposite sides are congruent. Those sides are congruent, but it's not a square because all the sides are not congruent. That would be my counterexample. It could be a rectangle. So this is a false statement. We've got the 4 congruent angles, which brings one of the t's in for the P part, but we can think of a figure that's not a square, which puts the F in there, which causes the value to be false. So this is a false statement. And a rectangle would be the counterexample. Let's look at the next one. If the sidewalks are wet, then it has been raining. Okay, so hypothesis, sidewalks wet, then it has been raining. So assume the sidewalks are wet. Is there another case that could cause the sidewalks to be wet other than it being raining? Well, maybe there was really heavy fog last night and there's dew on the ground, so it left the streets wet. Maybe somebody had their sprinklers on, so the sidewalk is wet. Maybe somebody was walking their dog and the dog peed on the sidewalk. The sidewalk would be wet. Those could all be counterexamples. So this is also a false statement. We can think of a case where, or assume that the hypothesis is true, which is one of these cases, but we can come up with a false conclusion. Example, like sprinklers. That would be our counterexample, and that would cause this to be a false statement. Okay, for 5, write the negation of each part of the conditional, then write the converse. So we want to write the negation. So if a figure is not a square, then it is not a rectangle. That would be the negation part, rather than rewriting it. Write the converse, the inverse, and the contrapositive. Now converse, again, swaps the Q and the P. So we want to write if a figure is a rectangle, then it is a square. They also want us to evaluate each one of these. If the figure is a rectangle, then it is a square. That's not true. A square is a rectangle that has all congruent sides. So some rectangles can be squares. So this is a false statement. Let's do the inverse. So the inverse, you leave the P and the Q where they're at, and you add knots. So change colors up. So if a figure is not a square, then it is not a rectangle. So let's think about this. You have a figure that's not a square. Okay, could be like a pentagon. Then it's not a rectangle. That makes it true. What if the figure was a square? A square is a rectangle, but a rectangle doesn't have to be a square. So I really can't think of a counterexample where this not a square. What if we had a rectangle? A rectangle's not a square. That makes this part. Oh, okay. What if a figure is a rectangle? That means it's not, well, yeah, if it's a rectangle, it's not a square, but it actually is a rectangle. That would be a counterexample that could let me say that one was false. That's a little bit tricky. Okay, let's look at the contrapositive. A contrapositive swaps the Q's and the P's and makes them both knots. So if a figure is not a rectangle, then it is not a square. So if a figure is not a rectangle, okay, not a rectangle, like pentagon. Pentagon isn't a square. This one switches up a little bit, like we can't assume, okay, what if a figure was a square? Well, a square is actually a rectangle. It's just a special rectangle. So that knocks the square counterexample like we used before out. I think this has got to be a true statement. Okay. Got to do the same thing for this one. If the game is not field hockey, then the game is not a team sport. We want to form the converse, which is Q then P. So if the game is a team sport, then it is field hockey. Now, this is false. I could think of football. Football is a team sport, but it's not field hockey. So that lets me know that that's a false statement. Let's do the inverse. Now, inverse is not P, then not Q. Okay, so if the game is not field hockey, then not a team sport. Let's think about that. So if the game's not field hockey, something that would be true would be football. If the game is football, that's not field hockey. But it is a team sport. That also means that I could say that's a false statement, because that would be a counterexample. Let's look at what was the last one? Contrapositive. So the contrapositive. That's not P, not Q implies not P. So if the game is not a team sport, then it's not field hockey. So if it's not a team sport, so since field hockey is a team sport, if it's not a team sport, that kind of excludes field hockey. So that actually makes this a true statement. Okay, write a biconditional for the following conditional. Determine if the truth value of the new statement. If two lines have the same slope, then they are parallel. So we would say two lines have the same slope. If and only if they are parallel. What about this? Okay, let's say we got like a 3D type situation here. I kind of messed the 3D thing up. Let's say you got a 3D thing here. I could have one line with a slope of 2 going this way. And over here, I could have another line with a slope of 2 going the other way in a 3D space. We could say that those lines have the same slope because that's changing y, we're changing x, yet those lines aren't parallel lines. So that would be one counterexample. Another example might be, what if you have two lines that actually are the same line? Like let's say we have y equals x plus 2, and let's say we have 2y equals 2x plus 4. These are really both the same line, but they're two different equations. So if I graph, say, the first line from a table, I'm going to get y equals x plus 2. So it's going to be like that. And if I graph the second one from a table, I'm going to have another line that basically overlaps the first line that I drew. I've got two separate equations, which basically give me two lines that graph on top of each other. So this is going to make the lines parallel, or no, this is going to make the lines with the same slope, but they are actually going to coincide, which is, I'm not for sure how that deals with parallel coincident lines. And maybe they have the same slope still, so maybe the 3D case is the one that would be the good counterexample for that. But if and only if makes it a biconditional. And generally, if you can write a biconditional, it's going to be true. So I'm not so sure about this coincide thing with the parallel lines. Let's look at number 8. Write the distributive property of multiplication over addition as a conditional statement. Okay, so distributive of multiplication over addition, let's say 3 times x plus 2 equals 3x plus 6. So there's the distributive property over multiplication. So so if a problem is to solve 3 times quantity x plus 2, then the simplified answer, simplification is 3x plus 6. Okay, so wrote it as a conditional statement, if, then. And for number 9, same thing. No, the number of people in the United States who are at least 100 years old grew about 66% from 80 to 210. Write that as a conditional statement. Let's see, so if 100-year-old population grew about 66% from 1980 to 2010, then that's not going to work. Let me erase that. Try something else. Think of a better one here. If you look at the population, from 1980 to 1910, from 1980 to 2010, then that population grew about 66%. Okay, so that was maybe a little bit tricky, but I think that would work. Okay, thank you.